7.1 Angle relationship in triangles. Each polygon has two types of angles in it, the interior angle and the exterior angle. An interior angle is an angle formed on the inside of a polygon, while an exterior angle is an angle formed on the outside of a polygon. The interior and the exterior angle added up equal 180 degrees. For example, if the interior angle is 60 degrees, the exterior angle has to be 120 degrees because when added up, they equal 180 degrees. When all the exterior angles on a triangle are added up, it equals 360 degrees. For example, if all three of the exterior angles are 120 degrees, when added up, they have to equal 360 degrees. Question 1. Find the measurement of angle A. If one exterior angle is 140 degrees and the other is 160 degrees, what does the third angle, which is A, equal to? Answer. To get the right answer, you have to subtract 160 degrees and 140 degrees by 360 degrees, and when you do that, you get the answer 60 degrees. Therefore, A equals 60 degrees. When two interior angles is added up, it equals to the third angle's exterior angle. For example, x plus y equals z, as shown below. Question 2. Find the measurements of angle z. So if one interior angle is 60 degrees and the other interior angle is 40 degrees, what is the third angle's exterior angle, which is z, equal to? Answer. To get the answer, you have to simply add up 60 degrees and 40 degrees. When they're added up, it equals to 100 degrees. Therefore, z is 100 degrees. These are just 3 important rules to find out the measurements of the angles in a triangle.
7.2 Angle relationships in quadrilaterals. Here is a parallelogram. We can give each angle a letter name so it is easy to identify them. Opposite angles like DAB and DCB are equal, and so are angles CDA and CBA. Did you know that angles ADC and BAD equal 180 degrees? And in order to prove that, we measure each of the angles, and ADC is 118 degrees and the other one is 65 degrees. After adding them up, we know that they equal 180 degrees. Here is the same parallelogram as before. The interior angles of this quadrilateral are ABC, DCB, BAD, and ADC. The interior angles within this quadrilateral are the angles that form inside the shape. The exterior angles are FGH, GHE, HEF, and EFG. The middle letter of the angle is where it starts. Here we have a square, and we are going to tear and put each of the ends together. This makes a complete circle, which is at 360 degrees. This shows how the interior angles of a quadrilateral equal 360 degrees. This also applies to exterior angles. So here is the problem. Sam works for an environment company, and he is going around houses around the neighborhood to plant trees. In order to protect the environment, he is given a bike that can only move straight. To make a turn, he has to manually move the bike. He has 3 angles of the location, but not the fourth. Find out the angle of the fourth location. We know the sum of a quadrilateral is 360, and so we can subtract the other angles from the 360 in order to find the missing angle. Here we are adding the unknown angles, which are 55 from location A, 105 degrees from location B, and 46 from location C. This equals 206 degrees. We can now subtract them in order to know D, which is 154 degrees. To make sure that we have the right answer, we can add up all the 4 angles, which equal 360 degrees. Before leaving his office, Sam's boss asked him to calculate each of the angles in case he went far ahead. We need to determine the missing exterior angles. Since we know that the straight line is 180 degrees, we can subtract each of the interior angles in order to determine the exterior. For angle E, we can subtract angle A from 180 degrees, which equals 125 degrees. Again, to ensure the right answer, we can add up all the exterior angles and see if they're 360 degrees. Now we will be finding the measure of the unknown angle, which is x. Again, like the previous formula, we know that the angles equal 360 degrees, so we can add them together to find x. First, we add up all the x's, which equals 17. We can then add up the rest of the whole numbers, which is negative 31. To make it easier, we can move the negative 31 to the other side and add it to the 360. adding up to 391 degrees. In order to determine x, we need to divide 17 on both sides, and 391 divided by 17 equals 23 degrees. This means that x is 23 degrees. We can now solve and note each of the angles. To find each of the angles, we can simply replace x by 23 as determined before. For the first angle, 5x minus 25, we can replace the x with 23 and multiply it by 5, and then subtract by 25, equaling up to 90 degrees. This can then be applied to the rest of the equations. As mentioned earlier, all the angles equal 360 degrees, so we can apply this rule to the quadrilateral as well.
Hello guys, today we're going to learn about angle relationship in a polygon. First, let's find out what is a polygon. A polygon is a figure with at least 3 straight sides and angles. Now let's learn how to find the total sum of all interior angles in a polygon. Now the formula of finding the sum is n minus 2 times 180. N is the number of sides in a polygon, and 180 is the total sum of angles in a triangle. So here's a quick, easy way to see this. And here. Now n minus 2, this equation right here in the brackets, this will tell you how many triangles there are in the polygon. Now you might be thinking, why a triangle? Well, this is because you can usually find a triangle in a polygon. And if you find all the triangles in that polygon and multiply that by 180, you'll get the sum of all the interior angles in that polygon. And that is what we need. So here we can show you an example. So let's cut this. This is a polygon right here. So let's cut this in as many triangles as we can. So we have one triangle, two triangles, say 1, 2, and 3 and 4. So it'll be 4 triangles times 180 is the amount of angles, total interior angles in one triangle. 4 triangles times 180. And the answer will be the total number of interior angles in this whole polygon. That's an easy way to know. Okay, now let's do a couple of examples. For the following polygons, what is the sum of all interior angles? So this polygon, let's see how many sides it has. That's 3, 4, 5, 6. So this polygon has 6 sides. So let's put that in the equation. So that will be 180 times brackets 6 minus 2 brackets. 6 minus 2 is 4, so 180 times 4, and the answer is 720 degrees. So this polygon has 720 degrees interior angles in total. Now for this polygon, this has 2, 3, 4, 5 sides. So it'll be 5 minus 2 times 180, and 5 minus 2 is 3, 180 times 3, and 180 times 3 is 540, so this polygon has 540 total interior angles. Okay, here's a question. What if you know the sum of the interior angles in a polygon, but you don't know how many sides does this polygon have? Well, all you gotta do is just reverse the steps you did to get the sum of interior angles. So now let's put this question into a formula. So here we need to know what are the interior angles. So we know there's a polygon and all the interior angles equal to 1,440 degrees. And that equals our formula, which is 1n minus 2 times 180. So now we have to find what n is right here. And to do that, first you have to take away, so it'll be 1,440 degrees divided by 180. And then you'll have to do 8 plus 2, which equals 10. And then 10 is the number of sides this polygon has. Right there. Let's do a couple of examples. So here you should do this one question yourselves, and I'll tell you the answer in a moment. So this polygon has 1,620 degrees total interior angles, and you have to find how many sides does this have. So here is the formula, and this polygon has 11 sides. So yeah, thank you for watching it, guys.
In this video, I'll be talking to you guys about midpoints and medians in triangles. First, I'll explain what a midpoint is. Here we have a scaling triangle. I drew something that is called a midpoint line. In order to create a midpoint line, I took the side highlighted in yellow and I split it in half. I did the same thing with the side highlighted in green. I took the two dots and connected them, and there I have created a midpoint line. Now, due to the fact that the midpoint split the side in half, I'll put my ticks, and on the other side as well. I drew the height, as we all remember the line is perpendicular. Now, the midpoint also cuts the height in half. The next thing you need to know is that the yellow line makes up half of the blue line. In other words, if the yellow line is x, then the blue line is 2x. Now I will begin talking about medians. What is a median? The line segment joining a vertex of a triangle to the midpoint of the opposite side. I will now teach you how to draw a median. Here we have a right angle triangle. Here's my vertex, and here's my midpoint of the opposite side. I take these two dots and connect them, and I've now created a median. Due to the fact that we did place a midpoint on this side, we are going to put our ticks to show that the two lengths are equal. Here's another rule you need to know. When we draw a median, it splits the area of the triangle in half, meaning this triangle and this triangle are equal. Since we do have 3 vertices, that means we can draw 3 medians. And all these medians intersect at one point. So, now that I've taught you guys the lesson, I will ask you now some questions. If triangle ABC has an area of 48 centimeters squared, what is the area of BLC? Pause the video in order to answer the question. So the answer is 24 centimeters squared. As remember, the median splits the area of the triangle in half. That is why we take the whole area of the triangle and divide it by 2. And we get our answer, which is 24 centimeters squared. Don't forget to write your therefore statement. So our second question is, if DE is 60 millimeters, calculate the length of BC. Pause the video again to answer the question. Now the answer is 120 millimeters squared. I will take you through how I got that answer. Remember how DE is the midpoint line, making DE half of BC? That is why I take the length of DE and double it. And that is how I got my answer.
7.5. Midpoints and diagonals in quadrilaterals. This trapezoid here possesses the following characteristics. It has either 2 equal sides or none, with a set of parallel lines. The angles that are from within the shape or the interior angles include either 290 degrees or no 90 degrees. The midpoints of the shape help us with the middle of the sides, so we're going to find the midpoints of each of the lines within this trapezoid. Now we have 4 midpoints, E, F, G, and H. And after marking the midpoints, we're going to connect them to form a parallelogram. It does not matter where we move the ends of the quadrilateral or how it looks, the connected midpoints will always form a parallelogram. This is the key characteristics. We now have a parallelogram. We're going to form two diagonals by connecting one end of the parallelogram to the other. The point of intersection can be known as the letter A. A shows how either ends are equal. This means that if one half is 5 centimeters, the other half is also 5 centimeters. And just like the previous point, A has formed a midpoint. Question 1. What shape is formed when a quadrilateral bisects at a 90-degree angle? Since we know that the bisection is at a 90-degree angle, you first draw a 90-degree angle. In order to form a proper shape, we will then draw the rest of the 90 degrees as well and then connect the lines together. This forms a rhombus. Therefore, a rhombus is formed when a quadrilateral bisects at a 90-degree angle. Question 2. Points E, F, G, and H are midpoints of ABCD. So if the area of ABCD is 49 centimeters squared, what is the area of E, F, G, and H? Since the shape is a square, we know that all the sides are equal. So we're going to find the square root of the area to determine the length of one side. 7 centimeters is the length of one side. Now since we want to know define the length of each of the triangles, we're going to divide 7 by 2 since that's the midpoint. This equals 3.5, and now we can use that to find the area. The formula for area of a triangle is length times width divided by 2. So 3.5 times 3.5 is 12.5, and 12.5 divided by 2 equals approximately 6.13 centimeters squared. We now have the area of one of the triangles. We're going to multiply this by 4 to know the area of the 4 triangles. So 6.13.4 is 24.5. And now that we have all that information, we can simply subtract the total area from the area of 4 triangles. So the area of ABCD is 49 centimeters squared, and 49 subtracted by 24.5 is 24.5 centimeters squared. Therefore, the area of EFGH is 24.5 centimeters.